Okay, Bismillahirrahmanirrahim. Okay, today, inshallah, we'll continue with chapter 7 material. We talked previously about arithmetic and geometric sequences. So, I have also previously shared with you the difference between a sequence and a series. Right now, we're still talking about sequences, okay? And I want to review this because the concepts that relate to geometric sequences are very parallel to the concepts that relate to arithmetic sequences. So arithmetic sequences are when you add, let's take this example, slightly different from before. Let's add 3 here. 2 plus 3 is 5, 8, 11, 14 here, okay? And geometric sequence is like, like this, okay. In an arithmetic sequence, you're always adding something to get to the next term. In this case, I added 3, okay, like this, and here I multiplied by 3, okay, correct? So whatever you're adding here in an arithmetic sequence, okay, this is called common difference. Now, if you're not told what the common difference, I'm telling you what the common difference is. It's pretty easy to find. Just take any two sequences, you subtract. Now, 14 minus 11 is 3. How difficult is that? Or take 11 minus 8. So it's very easy to find. Same thing with the geometric sequences. So the common difference is D. Okay. So, and I suggested previously there are two ways to define an arithmetic sequence and how to get the terms. Okay, the first rule is the recursive rule. That is, the way you get a sub n dependent on the term before it, a sub n minus 1, and then you just add the difference. And then we define the explicit rule, which does not depend on the term before it, but rather it depends on the first term, a sub 1, times, you're going to add certain number of d's, it's going to be n minus 1 times d. Okay, so this was the explicit rule and the recursive rule for arithmetic sequences. Okay, now we're going to do the same thing now for geometric sequences. Okay, now, so just to keep the math easy, we'll just use 2, 4, okay. Now this is a geometric sequence. Now if you didn't know that, let's say just somebody just puts the sequence, if you're not fair enough if it's geometric sequence or not, if somebody said, well, I think it's an arithmetic sequence. So what are you talking about? Because, 4 minus 2, that's the common difference here is 2, and here like 8 minus 4, the difference is 4. The difference is not the same, so it's clearly not arithmetic, right? But if you want to know if it's geometric, you divide 4 by 2, or 8 by 4, or 16 by 8, or 32 by 16, and they would all be the same, right? You multiply. This is a common ratio, okay? So this is a geometric sequence. In this geometric sequence, the first term, or a sub 1, is 2. And then you don't call it common difference, of course, because here you're multiplying by 2, right? So this multiplier, this is called a common ratio. Common ratio. And that's given R. In this case, common ratio is 2. Now, just like we had a recursive rule for geometric, for arithmetic sequences, we have a recursive rule for geometric sequences. Okay? Now the recursive rule means, okay, how do I get the term knowing the previous term? That's what that means. So a sub n, that's going to depend on the term before a sub n minus 1. Well, what do you do to What do you do to 4 to get to 8? You multiply by 2. What do you do to 8 to get to 16? You multiply by 2. To get to nth term, you take the previous term and you multiply it by the common ratio, the common multiplier. It's going to be r. Fair enough. And that's as easy as that. So the recursive rule for geometric sequences is you take the term before it and multiply by the common ratio, and ta-da, you got your term. Easy enough, right? Now, the explicit rule will be like, okay, I want to know a sub 5,721 based on the first term. I don't care what the previous term is. I don't know what the previous term is, right? So that would be the explicit rule. It's actually more useful in general, okay? So now let's look how we do this. Now, a sub 1, as we said over here, was 2. Let's use the example from here. How did we get the second term? We got the second term by taking the first term and multiplying by 2. Okay? That's this 2 over here. Okay? And we got the third term by multiplying the second term, which is 4, by 2 again. Like this, right? And we got the fourth term by multiplying, taking the third term and multiplying by the common ratio, which is 2. So every time we just adding another 2 at the end, aren't we? By multiplying. So a sub n is going to be the first term. And this is a sub 1. It happened to be 2. A sub 1. And you're going to multiply by a certain number of r's. It's going to be like r, 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 r. How many r's are we going to be multiplying by? Okay? The first term does not get any r's, right? The second term is the 1. You're going to, and the third term has 2 r's. The fourth term has 3 r's. The fifth term has 4. It's going to be 1 less than the term, r minus n minus 1. Right? Makes sense? So here's a sub 1 is a sub 1 times r to the 0. A sub 2 is a sub 1 times r to the 1. A sub 3 is a sub 1 times r times r. A sub 4 is a sub 1 times r times r times r, like that. Correct? So the explicit rule for geometric sequences is this. Okay? So the explicit rule for geometric sequences is a sub n is a sub 1, the first term, times the common ratio, to multiply to a sub 1 n minus 1 times. Got it? That's pretty easy enough, right? So here's the explicit rule, and here is the recursive rule. Now, these you kind of have to like go backwards and forwards. It's like knowing y equals mx plus b. If you're not comfortable with y equals mx plus b and you finish algebra 1, is there something wrong, right? Same over here. You have to be very comfortable with these terminologies. Recursive rule should not sound strange to you. Explicit rule should not sound strange to you. So I'm going to review this because it is so important, and we're going to finish this, and next time we shall elaborate on these concepts. So we talked about sequences. And we said sequences are just consecutive numbers lined, and they're the two very commonly talked about sequences. The reason they are commonly talked about is, believe it or not, as you might expect, just like the binomial theorems, they sounded so strange, but just saw how many profound common applications existed for a binomial theorem. So same thing over here. These have very practical applications. So sequences are, common sequences are discussed are arithmetic sequences and geometric sequences. And arithmetic sequences is when you're adding the same thing, a sub 1, and then a sub 2, a sub 3, and comma, etc. to a sub n. In these sequences, you're adding something common. That's called a common difference. Okay? In geometric sequences, okay, you're multiplying by a common ratio. So you're multiplying by a common ratio. Okay? So this is called a common difference. That's called a common ratio. Those terms you should be very familiar. Okay, and then the recursive rule for arithmetic sequence is easy enough. A sub n is going to depend on the a sub n minus 1, and just add one more common difference. And the explicit rule for arithmetic sequence was a sub n was dependent on the first term, plus you're going to add certain number of d's. How many d's? N minus 1 d's. Okay? Now the recursive rule for a geometric sequence was you take the term before it and multiply that by the common ratio. Whereas the explicit rule for a geometric sequence was a sub 1 times r, okay, the common ratio to n minus 1, that many times. Okay, so these formulas, they should be like, you know, ingrained in our minds and hearts. Now, just one last thing to bring to your attention. The explicit rule, you have to know the first term and the common difference, and you can get any term. Same thing, you have to know the first term and the common ratio, and then you can get any term. Whereas the recursive rule, you get the term based on the previous term and the difference. And the recursive rule for geometric sequences are the term, the previous term, and the common ratio. So this is like the basics of the arithmetic and geometric sequences, and inshallah next time we shall elaborate on this. Until then, as-salatu was-salamu ala rasulillah. Assalamu alaikum.